Hi everyone, this is Kshitij, and on this channel we talk about robotics, research and academia. In today's lecture, we are discussing lecture 4 of the TT102 lecture series on Intro to Python for Robotics, and the focus of today's lecture is to spawn a robot inside a simulation using a Python script. So let's get started. So if you remember this screen, this is basically the dev container inside Docker that we set up in the last lecture. If you've missed that lecture, you can find the playlist on my channel where we go step by step into setting everything up until this point. So now what we're going to do is we're going to switch to the terminal here. So as you can see, we have ROS Foxy and Ubuntu 20.04.06 LTS version. And we're going to start building our very first Python package inside the ROS workspace. So if you're not familiar with what these terminologies are, I encourage you to look up my lecture series TT101 where we went over the basics of ROS and we already explained all of this. But a quick overview is a workspace is in basically the entire kind of universe in which you develop all your source code, and all your source code lives inside this src folder, and your Python scripts or C++ scripts that you write are called as nodes. So first we have to develop create a package, and inside the package we will start writing the scripts. And this is the src, the source folder of the workspace, and then inside each of the packages you'll have the respective source folders. So let's start building our very first source package, ROS package, right, in Python. So we are going to use one of these commands, here. So I want to build a ROS2 package using the create command. And we're not going to call it this, we're going to call it spawn, let's say robot spawn package, and we give build type as amend Python because it's a Python package and hence it depends on RCL-Py. Once you press that, you're going to see, oops, we were not inside the src folder. So we're going to move robot spawn package to src. Okay, better. So we are now inside the src folder, and here you can see a couple of different things. So if you build a C++ package, you're going to get a file called cmakelist.txt. But since we are learning Python, that file is irrelevant for us. If you do not give these commands, additional commands, amend Python and dependency here, what it's going to do is by default it's going to create a C++ package. Then you would have to create the setup.config file and setup.py file manually. Since we already, and as you can see, you are going to get extension recommendations for Python. So of course we want to install it, and it's going to install inside the dev container, and you can borrow the name of this extension and also store it inside extensions.json, so that if you share this thing around like your Docker container, Docker image with anybody else, they are able to install these dependent extensions automatically out of the bat, and they don't have to do this one by one. So we don't have to do much here. It has already taken the package name because we did it at the time of creation of the package. And then we have, what else do we have? The config file is just a 2-liner, so nothing super fancy so far. So now we're going to do a couple of different edits to this file, setup.py that got created. So first things first, I changed the version number, so it's now version 1.0. I added a package directory that is a relative path so that it knows that this package lives inside the src folder that we have created here. And console scripts right now is empty, but we will give it the following command. Let's remove turtlebot, we just call it a spawn bot, robot spawner spawn bot main. So far so good. And inside our package.xml, I added this line number 11, which also adds an executable dependency on RCL-Py so that the compiler knows what kind of node this is. And then inside this repository, the package, we're going to create another folder src/robot spawn package, and inside this folder we are going to create our node spawnbot.py. Okay, so far it is empty, but this is where we're going to start populating our code. So before I start writing any piece of code, I like to add a sort of explainer comment on the top so that even I remember what's inside the code here. So let's explain that. So Python node to spawn a robot in. Okay, so I didn't fully like the way the structuring was happening, so I didn't want like an SRC inside SRC, so I did a little bit of refactoring and moved a few things around. So now as you can see, inside the robot spawn package that we just created, that init py was created already to make it a module. So I created a spawnbot.py, which is where we're going to code the Python node to launch the robot. But in the meantime, we're going to do a little bit of a housework, because to spawn a robot inside a simulation in Gazebo using ROS, we need two things. One is a model of a robot and the environment in which the robot is going to be deployed. So while looking around on the internet, I found a really nice looking environment that we're going to borrow off a GitHub repository. So let me pull that up real quick. So that's the environment that I found on this repository called Bunch of Coders. So this is a sort of office environment without the roof, which is really nice, because once we have a robot, we can navigate around, try and pretend like we're exploring rooms. Has an entry exit point over there at the end, and where is it? Yeah, entry exit point over there at the end, and entry exit point over here as well. So imagine like we move from somewhere outside the room, we enter from here, do a little bit of exploration, go outside from here. So that would make for a really cool demonstration. So that's what I'm after. So to get this environment, what we're going to do is we're going to switch back to our code base, which is here. And what we're going to do is we're going to build let's see, an environment, let's call it worlds. So inside this folder, we're going to create a file called office.world, and it is in a SDF format. So you could look up this repository by the Bokbots people, and which is this one. And here, let's see, if I go back one step, and so this is the robot that I'm going to borrow from here, and this is the world that I'm going to borrow from here. So if you keep scrolling down, you're going to find, let's see, where was the world file? Here, bokoffice.world. So if you scroll down to the readme file, you're going to find it, you expand it, you just copy paste this. And in a similar fashion, I'm going to borrow the robot as well, and we're going to set that up. So let's do that real quick. So just like we created a worlds folder, we need a URDF folder in the root here, and we're going to need two types of files here. So let's say we're going to call the bot ttbot, and then we need a file for Gazebo, and then we're going to need a ttbot.zacro file. Hang on, what was the extension? urdf.zacro. So rename .urdf.zacro. So now we're going to borrow the information directly from the GitHub repository for this. So let's quickly take that. Okay, so we're done pasting everything in here. So we have the URDF Zacro file and we have the .gazebo file. So with this, we have basically defined various joints and links of the robot, and we have also explained what the sensors are, what library to use to control which sensor. I guess that would be here. So as you can see, so you have this library for the Hokuyo. There would be a similar library for the camera. Let's see, the camera sensor is here. Yeah, there you go. So there's this, and then so these libraries you need to have installed. If you don't have these ROS packages, you'd have to do a sudo apt get install for these things. We're going to do these things next time, because that's when we're going to start controlling our robot, but for now we're just setting everything up. So let's see where we are. So we are here, we go into SRC and we go into the robot, yeah, and then we go into, let's see, that's our world file. Okay, there's our world, right? So we're gonna test it out to see that it opens okay. So we're gonna do office.world. Okay, now you're gonna think that nothing happened. Well, remember how we created this inside dev container JSON, we had forwarding ports. So you would have to open a local host pointing to this port, and that would then show you your Gazebo world. So let's open a new browser window and see how this looks. So let me show you how that works. So this is our window that you see. So I've opened up localhost pointing to port 6080, and as you see, it shows you the button connect. So when you click on connect, it's going to ask you for a password. The credentials are by default VS Code, which is a standard password, and then there you go. So that's our office environment. We can move it around. So then we just have to spawn our robot somewhere in free space, either inside the office or somewhere here, and then from the next time onward we'll be good to go to mess around with our robot. So let's do that real quick. Okay, so I've been debugging this for the past few days, and it turns out that spawning the robot was not so straightforward, especially if you're using Python. So here are a couple of things that I've done over the past few days, but now it finally works. So let's take a quick look. So as we're using the Python programming language as opposed to C++, all we have to do is to mess around with the setups.py file where we do all the settings. So these 3 lines of code are very, very crucial for the compiler to understand where your launch file is, where your URDFs are, and where your world file is. What is essentially doing is inside your directory, inside the install, once you do callcon build, you're going to get a share folder, and it's going to create a robot spawn package, because I think this line was already there in my previous setup.py. So it anyways created that, and it copied the package.xml file in here. But every time you do ROS2 launch and then name of the package and name of the launch file, it kept complaining it could not find the launch file inside the shared folder. So I added these 3 lines. Not the most elegant way of doing this, for example, if you have multiple launch files and multiple URDF or world files, but it does the job for now. So what this does is it basically makes a copy of those files over here, and once you've done this, you do a callcon build. And then it would basically, the compiler understands, okay, that this is the launch file, this is the URDF file, this is the world file that I have to look up for. So let's quickly run callcon build -- symlink install, and because there's only one package, we don't have to select a package. So it's quickly doing the robot spawn package compilation. Let's wait for it to finish. And voila, it finished and everything is fine, no errors. So now we are ready to do so this command should now hopefully work. ROS2 launch, name of the package and name of the launch file. Let's do that. Okay, Gazebo seems to be starting, waiting, GUI. Okay, so now everything seems to work. So let's transition over to our forwarded port inside a web browser to see what the Gazebo is showing. Okay, now that we are here, let's connect. Let's enter the password. And there you have it. There's our 4-wheel robot right there. Has a camera in the front. That's the lidar. That's the chassis. Those are the 4 wheels. It has a ball as well in the environment for you to push around. And then this is the office environment. So it's spawned in here. So far so good. Everything works fine. So inside our code environment here, you can see I'm doing almost everything through the launch file at the moment. So it's basically finding the URDF file, it's resolving the double quotes with the escape sequence, and then it's basically looking for, it's calling the Gazebo service, libgazebo ROS factory, and then spawn entity. This is how it is spawning the robot inside the world. So now the homework for you, basically like take home assignment for you, is to figure out where in this launch file can we add the parameters x, y, z, r, p, y to modify the initial pose in which the robot spawns within the Gazebo environment. So do it with the launch file for now. So if you're able to figure that out, you can easily make a pull request, because I am actually, let me show you this before I forget. So I've made a GitHub repository now which has all of this source code, including the robot spawn package that we're currently building, the dev container in which I made the changes in the Docker file before, has a very well laid out README file, so you can read everything that I'm doing. I'm adding links to the stuff that I'm referring to, adding package details and stuff. So I'm incrementally building this as I'm doing this thing here. So yeah, feel free to make a pull request for this if you're able to figure out how to add those parameters inside the launch file, and then modify the initial spawning pose. So pose is a joint position and orientation together of the robot. So in the next lecture, what we're going to do is we're going to query Gazebo and write Python code. So probably we don't need the spawn robot.py, but more like move robot.py code next time, so that we're able to move a robot from one point to another point, or we can make it chase that ball that is already inside the environment. But we're going to do everything end to end using Python code. So see you in the next lecture. I hope you're enjoying the TT102 lecture series so far. If you are, be sure to like, share and subscribe, and stick around for the subsequent lectures.